Oh, and we're back. Okay, so lesson 4, Ordinary Simple Annuities. This time we want to be able to try to rearrange our formula and solve for payment. Now, when is this useful? It's actually super useful. I was asking myself that at age 15, and I'll show you the example that I was interested in at the time. Okay, so I'll give you some details, okay, with respect to that. I was interested in having $500,000 when I was 15, and I said, all right, well, if I take like 20 years, how much would I have to be putting away? And then I was interested in the stock market and so on, so I'll give you some details in that. So that's one example of trying to figure out, how much you want to be putting away at certain time intervals. Another thing is interesting with payments is, for example, if currently, you want to buy, let's say, a house, or you're taking on some debt. Okay, so you have a total amount of debt. So let's say you have $100,000 in debt, and you want to be able to pay that off over time at some interest. And you wanted to know, well, what will those payments be? So those are cool questions to ask yourself, and they basically just come out directly from the Ordinary Simple Annuities formulas, either the future value or present value. So I'm going to just show you. We'll do a short derivation. This one isn't as kind of chaotic as from lessons 2 and lessons 3. And by the way, so in lesson, I guess, number 2, I talked about future value and how to derive it and do some examples. So I'll put a link up above. You can click on that one if you want to watch it. It's definitely useful before watching this one. And then we started getting into trying to solve for the present value. So moving all the payments all the way back into the present to a certain focal time at the start. And for that one, so that was basically lesson number 3. And so I'll do a link for that as well, so you can have that link if you wanted to watch those before you start watching this. So here on the screen, what you see a bunch of payments, all right, starting from the beginning and then going all the way to the end. So again, remember, our payments are at the end of each term. All right, and we are focusing on a simple annuity, which means that your payments and your compounding are aligning, so the terms are the same. Okay, so for example, if you're going to be having your payments monthly, then also your compounding is also monthly. If you're going to have your payments quarterly, then your compounding is also quarterly. And if your payments are annually, then your compounding is happening annually. So that's what you have to keep in mind for the simple annuities. All right, and then for the ordinary, it just means that we are shifting them towards the end of each term. So I have here the 2 formulas for the future value and present value. All right, and what I'm going to do is I'm going to take the future value formula first, and then I'm going to derive and basically just rejig. All right, so do a little bit of algebra. Okay, so relocate the variables so that we isolate for the payment, because we want to be solving for the payment. And then I'll do the same with the present value formula. You'll see that it's exactly the same. And then we'll use those actual formulas to try to solve a couple of examples. Now, of course, don't forget, as nice as the formulas are, I mean, if you're going to do annuities, definitely do it with some business calculator. And I will do a video on the examples and then show you how to input that in for the payment as well. So I'll do a link up above once the video is ready. Okay, so you'll have that link if you want to see how it's done on a business calculator, isolating for the payment, which is probably the easiest. So in any case, so you can imagine that we have a certain amount of payments. So I'm going to start here. So let's say this is payment number 1, payment number 2, payment number 3, and so on. And it goes all the way to payment number n. All right, so I'll put n here. So this would have been n minus 1, and this would have been n minus 2. Whatever your n is. So n may be 100, okay? It may be just 20 or 10 or something like that. So we have a certain amount of payments, okay, that we're carrying. We are assuming that we know what the interest is. Okay, so that is given to us. And unlike in the previous lessons, okay, let's assume that we either know the future value or the present value. All right, so if you know your future value, let me remove the present value from here for just a second. Actually, let's go back here. I'm going to keep that for myself. So let me maybe cut it so I can paste it back in. So if you have your future value, all right, and someone gives you this future value, if you know your interest, all right, and then you know how many payments you have, then you can isolate this formula. All right, so what I'm going to do is I'm going to isolate it. So I'm going to first multiply both sides by I. So if I multiply this side by I, so the I obviously will cancel from there, but it's going to appear on the other side. So I'm going to have the future value multiplied by I here is equal to now the payment. And now all I have on top is there that 1 plus I to the n minus 1. All right, so that's all that I have there. I'll put it in brackets in here. Now, again, since I want to isolate for the payment, I can now divide both sides. So I'm going to divide it by exactly this. All right, so let me do that. So let me copy, paste it, because that's the easiest thing to do here. All right, so that I have that there, and then I'm going to have to do that on the other side as well. All right, so let me paste it back in here. Let me make it a little bit smaller. Okay, so it's going to be right there. And I'll remove this little tiny dot there. Now, if you do this, then these terms, so this term, all right, so or this factor will cancel off with this factor, so that will be gone, and all you're going to have is just your payment on the right-hand side. And that is your payment formula. So let me rewrite this formula. Okay, so I'll do the rewriting. So I have my payment, so I'll keep my payment right here, and payment is equal to, so notice on the top, okay, I have future value times my I, so maybe, okay, I'll do this. Okay, I'll just swap those out. It doesn't really matter. Okay, and then I can divide it by 1 plus I to the n minus 1. So if you know your future value, your interest, and the number of payments that you have, then you can use this formula to try to solve for your payment. All right, so instead of using a business calculator, you can just plug everything in here, and then you can go ahead and solve it, which isn't really that difficult, right? Now, what if you had, so that would be your formula for the payment if you know the future value. What if you know the present value? All right, so here, in terms of the present value, so let me rewrite it because I cut it away there. But now since I've used some of that, so let me do this. Okay, so we have our present value was equal to our payment. All right, open bracket, and this was 1 minus 1 plus I to the negative n, and then divided by I. So if you know the present value, you will do exactly the same thing in terms of the isolation. So you can multiply both sides by I, then you can divide both sides by the factor. All right, so you would be doing it by this factor right here. Okay, so this would have been 1 minus, okay, so all of this, let me kind of make it maybe as a whole. Whoops, in here. All right, so you have that. And now if you multiply by I and then divide by the numerator, you're going to be able to solve for your payment. And your actual formula in that case, so I'm just going to write it for you. You can double check it for yourself. So it would have been I times your present value divided by 1. Okay, in this case it's minus 1 plus I to the negative n. And those are your two formulas. So formula 1 and formula 2. So notice that one of them is with future value and the other one is with present value. And you will have to use them accordingly depending on what is given in the question. So let's try that, okay? Let's try those questions that I was talking about initially. So here it is. So here's the first one. So it says, Bartek at the age of 15 wanted to have $500,000 in 20 years. It's a nice thing to have. Makes your life a lot easier. You don't have to work as much. And if you add 20 years to 15, you notice that it's 35. Now, for a 15-year-old or even a 20-year-old or however old you might be at the moment and you're studying this, you'll be like, oh my gosh, I got to wait 20 years. 35 is not that long, and it's not that old, okay, or even 40 or 45. But if you have that amount of change for yourself, it's pretty cool to have. So let me highlight all of these things. So I want to have $500,000. I want to have it in 20 years' time. Now, I noticed at the time that the data for the overall US market, so basically it was almost like a century, it was hovering around 9%, and that was with the dividend, okay, compounded annually. So that was not a bad return. Now, I have no idea how it's going to be in the future, but when I was 15, it actually turned out not bad for me. So 9% compounded annually. And here are the questions. What amount of money would Bartek have to invest each year? All right. So let's think about that. That's basically over 20 years. I was asking myself, okay, how much do I have to put away and invest each year so that in 20 years down the line, I have $500,000? That's the question that I was asking. So visually, if you look, so if I take this whole thing, let me copy this right here so that you can see what I am referring to. All right. And I'm going to make it a tiny bit smaller. I think it will still do the service for us. So notice that we are starting. So this is my start. So this is when I was 15. And then every single year I would accumulate some amount of money. All right, so that would have been year 1, year 2, year 3, and this would have been, year 20, year 19, year 18, and at the end, what I wanted to have $500,000. That's what I wanted. All right, so now what I was asking, okay, what are these payments? How much am I going to have to be putting away? Now, the interest here, so let me write all of these things. So the future value was to be $500,000, right? Now, it says it's compounded annually. So my interest, I, is 9%. Now, 9% is 0.09. It's compounded annually, so it's just divided by 1. It's still 0.09. Now, N, so number of terms here or payments that I have, is 20 because it's 20 years and I'm only compounding once per year, and that's how I want to be able to invest. So notice what I do is I have future value, I have I and I have N, and I want payments. So I'm going to take this formula right here. So copy. I'm going to paste it in here. And now that I have this formula, I can just substitute all of this in. So my I, so 0.09 multiplied by, now my future value is actually quite a lot, so it's $500,000 divided by, and then let me plug this in, 1 plus 0.09 to the N, so this is 20 minus 1. All right, so now let's take out our calculator. So I'm going to take this thing out. Let me shift it over to the other side so that you can see it. And let's work this entire thing out. All right, so that's what I want to do. So 0.09 multiplied by $500,000. 1, 2, 3. All right, so that's going to be 45,000. And now I want to take this 45,000 and divide it by, I'm going to put all of the other stuff there in brackets. Okay, so in the denominator. So be careful how you are dividing these. Okay, so this thing right here means you're dividing. And what I'm going to do is this. I'm going to add brackets in here so that I keep the entire denominator in brackets. So notice, first bracket, so that's the first bracket. Now the second bracket, so I'm going to open another bracket. 1 plus 0.09, close bracket, so I'm right here, to the exponent of 20. All right, so that's that. And then minus 1. And then don't forget your bracket at the end. And hit equals. So my payment, and I'm going to just round it. So 977.3. All right, if we round it to the cent, okay, that's what it would be. Okay, now, I mean, for this particular example, of course, if this is something you had on a test or something, you can leave it in that way. I'm just going to approximate it. So just keep it to the dollar for the moment. So I would have to actually put away, you know, more than $9,000. And, you know, when you're 15, you're like, oh my gosh, how in the world am I going to do that? I mean, it's nice to have $500,000 down the line, but how am I going to do this? All right, so let me just go back and take a look at the second part of this question. What amount, sorry about that, what amount of money would we have to put away per day? So when I started thinking, I'm like, well, 9,000 something, that sounds like a lot. And then I said like, okay, well, what does that mean? So let's say per day. So this was per year, right? So this amount was per year, but in part B, they wanted to know, okay, this is per year, so annually. Those would have been my payments that I would have to make. Now, what if it was per day? Well, so there are about 365 days in a year. You know, in business terms, sometimes we divide by 360. It's up to you. All right. So now if I take this answer and divide it by 365, hey, that's not bad, I thought to myself. That's around 26 bucks, right? So this is, let's say, approximately $26 and let's say 78 cents. So let's round this off. Let's say, all right, so that's about 27 bucks. That's not bad, 27 bucks a day, right? So if you're working and you're, let's say, I mean, back then, you know, you were making that much, but, you know, even if you were making, let's say, 8 bucks an hour or something like that, or 5 bucks an hour. I mean, I remember, you know, I used to make like less than $4 an hour when I used to start at some point. But in anyways, okay, so this is $27 a day. That is definitely feasible, you know, and that's what I thought to myself. So this was a cool question to see how you can apply this concept, you know, with annuities and try to project things out into the future for yourself. Now, if you wanted to have $1 million or something like that, you know, you would have to put away a little bit more than that, and you can do that calculation for yourself. All right, so that was question 1. Here's another question for you. A debt, so now a debt of $100,000 is to be paid off in 10 years' time. Okay, so 10 years' time. If currently the interest rate for the debt is calculated at 3.6% compounded monthly, then what would the monthly payment be? Okay, so let's highlight these. So 100,000, so a debt, so that's actually your present value. We want to do it for 10 years. We're compounding monthly and we want to know what the payments are per month. So if you write these out, so we have present value is equal to, okay, so we had taken on $100,000. Then the N, so notice it's 10 years, but it's 10 years per month. So we actually have 120 as our N, so number of terms. And then our interest, okay, is 0.0, this is 36, but this is divided by 12. Let's take a look. I think this actually nicely works out so that we won't have to leave it as a fraction. Perfect. So this is actually 0.00, whoops, sorry about that. Okay, 3. So that's our interest. Remember, that's monthly. And now I can go back and I can calculate my payments just by using our payment formula. But now I'm going to use, so copy, I'm going to use the present value formula for this one. So let's paste it in. And now I can substitute all of this in here. So my payment equals, so my I, so 0.003 multiplied by, this is 100,000, divided by, and this would have been 1 minus, and 1 plus I, 0.003 to the negative, and then N was 120. So it's going to be annoying to put it in a calculator, but so be it. All right. And now again, don't forget, because of this division, when I'm putting it in the calculator, what I like to do is I like to put these in brackets. The reason why I put it in brackets is because if you don't put it in brackets, your calculator might not divide by the entire denominator. So, a trick is to always put the whole denominator in brackets so you have it guaranteed. Okay, so here we have 0.003 times, this is 100,000, equals, so that's what we have there. And now we're going to take that answer, divided by, okay, and now, so bracket, so again, so don't forget, so bracket, all right, and now we have 1 minus, okay, so now the other bracket here, this is 1 plus 0.003, close the bracket, that's that, to the exponent, but now don't forget, this is negative, all right, so that's that, and then we got to close the final bracket, so equals. Okay, so this turns out to be 993.55. All right, and that would have been your payment, and those are your payments actually per month. All right, so that's what you would have had. So this whole thing, okay, so if we had that, okay, and now let's say if I this is per month, okay, and now let me get rid of this thing, that would have been the payment to pay off that $100,000 over the 10 years that you have. All right, so, and because it is a debt, so obviously if you would have taken this $993 and actually multiplied it out, there is interest accumulating, so it's going to be more than 100,000, right? So, all right, so I hope you found these examples useful. These are actually neat examples. I really like this one. So this example in terms of trying to think ahead. Now, of course, almost nobody does this. There's just the crazy kids, I guess, like myself, maybe. Okay. All right. So thanks for watching. We'll see you in a future video. Okay. And I'll try to also do a video with the calculator, as I pointed out before. So you'll see that under lesson number 4. Okay. Cheers. We'll see you in a future one. Bye.